All right, so on the back for the notes, the first part, learning target 1, was just knowing what the 4C method is for inference. So there's the framework for doing inference if you want to pause the video and get that written down. Choose is choose the procedure, define the parameter and confidence interval. In the check section, you're going to check your conditions. The so what is not necessary, right? That's just like making sure that we know why. Like a follow-up question might be, why did we check random? Why did we check the 10%? So make sure you know why. The calculate portion is where we do the calculations. For now, that means we're going to show the general and specific formulas, plug in numbers, and calculate. Later on, when we use more technology to do that, we'll talk about how that changes. And then conclude, we're going to interpret that interval in context. Okay. Learning target number 2 is about choosing a sample size. So there will be questions where you are given a specific margin of error and you have to pick what sample size you want to get that margin of error. So when you have this type of question, you are going to start with the portion of the confidence interval that is the margin of error. So remember, the margin of error is always the critical value times the standard error. So p hat 1 minus p hat over n, right? And what you're going to end up doing is you're going to plug in for, let me get a marker. You're going to plug in a number for this and this and this, and n is going to be your thing that's unknown. So you're going to do the math and the algebra to solve for n, okay? So here's a couple of things that you need to know about this. When we don't know p hat, which most of the time we don't, when we don't know p hat, when p hat is unknown, because to get p hat, we need a sample size, and if we don't have a sample size, we can't find p hat. So when p hat is unknown, we use p hat equals 0.5, just to be conservative in our guess. We're giving ourselves lots of room for error. So we're just going to plug a 0.5 in for p hat. And then when you solve it, if n is a decimal answer, always round up. Those are the two things. So on this, you're going to have to remember some algebra to solve this out. The check your understanding is this kind of problem. Okay, so a community activist group in Austin, Texas wanted a particular issue to be placed on the ballot of the upcoming election. The group turned in a petition with 24,598 signatures, and to make it on the ballot, 20,000 ballot signatures are needed. So at least 81.3% of the signatures from the petition must be valid. It is too time-consuming to check all of the signatures, so a random sample of signatures is checked. The county clerk that is checking the signatures needs to be 95% confident that the true proportion of valid signatures are estimated with at most a 2% margin of error. That's our key right there. Margin of error has to be 2% or less. Question 1 says, using a conservative estimate for p hat, how large of a sample is needed? So we're going to start with our margin of error calculation. So margin of error is equal to z star times p hat 1 minus p hat over n. I'm just doing the formula. So now we're going to plug in some numbers. We want our margin of error to be 2% or less. So 2% is 0.02. The z star for 95%, right? So z star right here is based off this 95% confident, right? So margin of error, 2%. 95% confident z star is 1.960. Okay, that's where that comes from. Oh, there's the bell.